So mixture problem number 6, guys. The background information tells you that we have a family of 6 adults and 12 children going to this theme park paying $210, right? A second family with 4 adults and 8 children going to the same theme park paying $140. Okay, don't forget, this is the same theme park. It means that the price per adult and the price per child should be exactly the same. And your ultimate goal is to figure out what is the price for each, right? Each adult and each child. So let's get started. If you read the problem and read the question that's being asked, you notice that they're asking you for the price per adult and per child. Then, if you want to start, ooh, sorry, you did not see that one. Okay, all right, that's fine. I'm gonna go Man in Black style on you and make sure I erase your memory. Okay, done. Okay.
You don't have that lighting thing though.
What's your name?
I'm gonna look at
the board.
Oh, I forgot the answer.
Alright, good, cool.
We can pause
now,
the video.
Let's think about this. We read the problem. As always, before you start writing the equation, what do we need to do first? Always. Yes. Define what?
The variable.
Thank you. Define your variables. So in this case, how many variables do we need? 2. And specifically, the reason I'm using X and Y is because I want to make it easier to graph later on. Although you can certainly choose A for adult and C for child, right? It's up to you. But as long as if you want to start graphing, you want to convert back to X and Y for it easier to have a way to graph. So let's just say I'm going to declare great. It will be 2. Is that great?
Hey, I would like doing that.
Let's play the game on video.
All right, cool. So let's start this again. Hopefully I can write it correctly this time. All right. So let's say X. What is X?
Adults.
The cost for
Adult.
an adult, per adult, right? Okay, so be very careful when you say it. So this is the price per, and the price per adult is measured in what unit?
Money.
Money is in dollar. Okay, so it's in dollar. So I'm just going to go and mark that. You know it's about money. And so what about Y? What should we define Y as? Yeah, price per children. Good. So we're going to go ahead and price
child?
per child. Yeah, you're right. Per child. Singular. Yeah, you're right. Dollar sign as well. It's fine. Okay. So I have X and Y. Let me ask this group right here that has Brian in it, right? What should my first equation be? What do you think? That particular group right there. What did you come up with your first equation based on the information given? Okay, so you're telling me. Okay, I'm going to go and write what you tell me. 6x plus 12y equals to 210. Okay. Here we go. Here's the next part. Jose, can you tell me though, what does 6 times x represent? See, I write the equation, but I need to make sure that you understand what you're writing. So what does 6 times x represent?
The amount for 6 children.
Interesting. Let's read that x again. X is the price per adult. So you're
adult.
telling me that 6 times x will give me the price for 6 children?
For adults.
Ah. So are you telling me that if I take 6 times x, what I will get back is what?
The price for 6 adults.
The price for 6 adults. So basically the money that I have to pay for 6 adults to enter the theme park, right? So can we also use that same reasoning to apply to 12y? So if you take 6 times x plus 12 times y, what unit should you get back? Money. Also money. And do we agree that if the left-hand side is money, then the right-hand side has to also be money?
Yeah.
And is it $210 is money?
Yeah.
So that's what I want you to check for as well. You want to make sure that there's a balance of unit. If the left is money, then the right has to be money. If the left is about people, then the right has to be about people as well. You cannot mix and match unit. Okay, is that clear? Okay, now that we got a first equation now, what should my second equation be? Yes?
4x plus 8y.
4x plus 8y, you said, equals to?
140.
140. And do you agree that this is the second family?
Yeah.
Okay, we all understand how we got these, right? All right. So now that we have our 2 equations that we want, what is our next step? What should be your next step after we obtain 2 equations? Trent, what do you think our next step should be after we obtain two equations? What do you think? No, not even before that step. Yes?
You can simplify the equation.
You can if you want to, but let's say I don't want to simplify. What should my next step be? Yes?
LC down.
That's even later. I want before that. Yes?
Solve for one variable.
Well, that's the goal. Yes, but how do we solve that?
Does it start with an E?
Huh?
Does it start with an E?
Even before that too.
Eliminate.
Okay, so S and E, so we should consider what?
Sublimation.
You get into the point, you're right, but if we obtain these two equations, you should just consider, wait, should I go with elimination
Yeah, that's what I was thinking.
or should I go with substitution?
Oh, I know.
You see it?
I know.
So you should have that on your mind. I have two equations. Which method should I use? Elimination or substitution? Now is a good time to decide. Which one should I use? Yes.
Elimination.
Why?
Because variables are already lined up.
Okay, good. So they're all aligned. Here's the keyword. All aligned, right? And for substitutions, it's good when it's what to use when you want to use substitution. What has to happen for you to use substitution? Simpler equation and the variable is already solved for. So simpler equation with one variable already solved. Okay, like x equals to something or y equals to something, so that's when you use substitution. But in this case, we're going to use elimination method. If we're going to be using the elimination method, guys. Which column should we get rid of? Okay, why x and not y?
Smaller.
Smaller, thank you. We want something simpler, right? So that's the reason why we pick x over y. Not that it's wrong to pick y. It's not. It's absolutely correct too. But we want to pick something that is actually simpler to deal with. And 6 and 4 is actually smaller than 12 and 8. Now, what should we do next then? LCM, very good. Least common multiple. What is the LCM for 6 and 4? LCM, not the lowest common denominator, you know what I'm saying? Right? Or wait, no, I'm sorry. LCD is LCM. Never mind. I'm not saying a lowest common factor. What is the LCM for 6 and 4? 12. So 12 is my target number, and if I want to make everything 12, what should I multiply the top with? 2. What about the bottom equation?
3.
By 3. So watch what happens. If I multiply that 2 into the first equation, what do I have?
12.
12x plus 24y equals to 420, right? Okay. What about the red equation, the second one? 12x plus 24y as well equals to? Oh, interesting. What did you just see?
You almost tripped.
I'm saying the equations. What did you see?
They're both the same.
They are both the same. So that means if you were to graph both of them, will you see two different lines?
No.
No. You will see this. What happened?
It's gonna be stacked on each other.
Okay, stacked on each other. What case is this? Do you know? Okay, so we're saying this is a consistent dependent case, right?
Yeah.
What does it mean to have a consistent dependent case?
Overlap.
I know, but in terms of solutions, what do you
All solutions.
all solutions? So you basically say infinitely many solutions. Infinitely many means if I have like 1 million groups, I should have 1 million answers. Is that true?
Yes.
Because it says infinitely many. You can all have different answer and they're all going to be all correct. Why is it like that? Let me show you why. Last night, well actually yesterday, I said, well guys, for this particular problem, it's actually good to use GeoGebra to figure out the answer. And let me show you how it's done. If you have downloaded the software already, let's boot that up. Here's GeoGebra right here. All right, here we go. I'm going to go and enter my first equation. What's my first equation?
6x plus 12y equals 210.
Okay, so 6x plus 12y equals to 210. Next equation.
4x plus 8y equals 140.
Okay, so before I do anything to it, notice that I don't see any line up here. Does it mean I did it wrong?
No.
Not really. What you need to do is actually change your axis to make it bigger. How do you do that? You can either zoom out, zoom in, or you can click on this Move Graphic View right here, and click on the axis itself and drag inward.
What?
See it? You can actually do that to increase your interval. Look at that. And now, as you start making it bigger, you will start seeing your line. And same thing, you can actually do the same thing for your x-axis as well. And there you have it. You see it? There you go. So, this is your line. Another unique feature for this is your line doesn't have to be black all the time. You can actually click on this line right there, like that, and do object properties. Now you can change the color. Let's make it pink. Okay, that. And I can also change the style. I can also make the line thicker, just for you to see. So let's make it thick. I can also change the line style to make it a dotted or dash or whatever, you know, depending on the need. But let's just say I use that. Okay, here's my first equation. Now, give me the second one again.
4x plus 8y.
4x plus 8y
140.
equals to 140. Watch what happens carefully. Okay, don't blink. Do not blink. Important. What did you just see? Nothing. Wait. The reason you can't see is because it's actually, do you notice that there's a black line on top of that pink? Okay, fine. Maybe if I change the color, it will make it easier for you to see. So let's change this color to a brighter color. Make it
I don't like yellow.
this one. Look at that. Do you see the black line now?
Yeah.
Do you see that now?
Yes.
You see the black line right there?
No.
See? Shh.
I see dotted.
Okay.
I don't see it.
Alright. Fine. If you don't see that still, I can actually...
The red line and the blue line and make it a purple line.
Right. I can certainly change it for you. Okay, so let's change this color. This color into a... What color should I change it to?
Yellow.
Yellow? No, it's going to be hard to see. Make it red.
Red.
Okay, watch this. I know it's red. Oh, yeah, let's make it thicker so you can see. Here's a thicker line. Or should I make it dotted?
Dotted.
Okay. Oh, you see the redness? And make it red.
Nope.
Oh, there it is. Now you see it.
Oh, yes.
Do you see it?
Yeah.
So clearly you see one line on top of the other line. Okay, so what does it mean though? It means that every point on this line is your possible answer. Has to be on the line though. So how does it work? In GeoGebra, there is a feature call. If you click on point on object, there's a feature called point on object. So click on that. And now let's just say this. I pick a point on the line. Let's say pick somewhere that's easier to see. Let's say that one. Oh my gosh, look at that. So that means what? It means for X is 15. X, I declare that to be adult, right? And children is 10. So it means if you test this out, $15 per adult, $10 per child, and you plug it in, it will work out just fine. And that is just one possible answer out of many. Because on the same line, I can also pick another point right about here and say, oh yeah, or it could be $7.05 for each adult and $13.98 per child. Or I can also pick somewhere over here and say, oh yeah, it's $22.47 per adult and $6.27 per child, as long as you have a point on the line. And the reason it's infinitely many is because you can actually pick infinitely many points, and you will have the answers. But here's my next question for you though. Is it okay for me to pick a point that is on the left-hand side of the x-axis?
No.
Why?
Because it'll be negative.
Thank you. It'll be negative. Because you now have negative price, you know what I'm saying? Okay, makes perfect sense. What do you think of that?
Pretty cool, I guess.
Okay, so I highly suggest that you learn to use this particular software right here to enhance your presentation. Imagine if you're going to be doing something like this. Remember when you do your presentation up here, you can pre-record first if you want to, and then just play it as you present. Okay, so there it is.